Jai Shri Gurudev. Good morning to everyone, students. Welcome to chemistry class. In the previous class, we have studied about quantum numbers. Now, in this class, we are going to study rules or principles used to fitting electrons in various orbitals. Here, there are some principles. Those are used to filling electrons in various orbitals. Those we are studying here. The first one is Hubble principle. The first principle is Hubble principle. Here, Hubble is a German word. It means building up. The word Hubble means building up. It is a German word, means building up. It means filling of electrons in various orbitals. What is the statement of this Hubble principle, or what is the rule of Hubble principle? That is statement. This Hubble principle states that filling of electrons takes place in the increasing order of energy of orbitals. That is filling of electrons in various orbitals takes place in increasing order of orbital energy. Is the Hubble principle. It means the electrons are filled in various orbitals in their increasing order. Means the orbital which having lowest energy is filled first, then orbital which having highest energy. Now to know the which orbit having highest energy and which orbit having lowest energy, just we are writing a diagram that is called orbital energy diagram. The orbital energy diagram is writing like that. That is 1s orbit, 2s orbit, 3s orbit, and 4s orbit, 5s orbit, like that. This 1 to 3 indicates the number of shells, also high energy of shell. This S is the L value, that is azimuthal quantum number. Then after 2s write 2p by leaving the first row. So 2p, 3p, 4p, 5p, like that. There is so many orbitals. After 5s there is 6s, like that. Just I am writing up to 5s. Then 3p, after 3p, 3d, and 4d, 5d. Then after 4d give 1, that is give 3d. Then 4d, after 4d 5d, then 6d, like that. If you want to write here 6s, 6p, 6d, and 5, 6. Sorry, this is 4d, 4f, 5f, and 6, like that. So this is the orbital diagram. This is called as orbital energy diagram. Now the filling of electrons in these orbitals is by putting the curve or arrow like that. So observe how I am writing the arrow mark. Why we are writing the arrow mark like that? It means the filling of electrons takes place from right to left. Means the 1s orbit is filled first. Then after filling 1s, the arrow is moving like that. That is 2s. Then after 2s, we are filling first 2p, then 3s, because the curve or the arrow mark is moving from 2p to 3s. Then after filling 3s, the next one is 3p, then 4s, not 3d. Then after filling 4s, the next one is 3d, then 4p, then 5s, like that. This whole thing we called orbital energy diagram. This is called orbital energy level diagram. So here what is the order of orbitals in their energy is writing. The order of energy of orbitals is so observe the 1s is filled first, that is 1s orbital having less energy, means the orbital having less energy is filled first, then orbital having highest energy, that is the statement of above principle. 1s orbital having less energy than 2s, which is having less energy than 2p and 3s, then after 3s 3p, then 4s, then after 4s 3d, like so on. Like that we are using the filling of electrons in an orbital is called Hubble principle. The next one is Pauli's exclusive principle. That is the second principle or statement. It states that an orbital having maximum 2 electrons with opposite spin. An orbital have maximum 2 electrons only with the opposite spin. Is called Pauli's exclusive principle. Here Paulis is a scientist. He only found that each orbital is accommodated only 2 electrons with opposite spin. You know there is 2 types of spin, that is plus of spin and minus of spin for every electrons, right? Plus of is nothing but the arrow mark is showing upside and the minus is nothing but the arrow mark is down showing downside. So here one orbital is represented or written like that. If you take the s orbital, that is 1s orbital here, we are taking 1s orbital. This orbital having maximum only 2 electrons with opposite spin. It means one electron is upside and one more electron is showing downside like that. Or you can write like if you wish to write like, you can write like. Means full-headed arrow you can show or half-headed arrow. Always we are showing half-headed arrow when we are writing 2 electrons in same orbital. So if you write like that, no wrong. So just remember, plus of is nothing but arrow is opposite, minus of is nothing but downside, and the Pauli says that only the orbital can accommodate 2 electrons with the opposite spin. This is the Pauli's exclusive principle. Then the third one is Hund's rule of maximum multiplicity. The third one is Hund's rule of maximum multiplicity. Hund's rule of maximum multiplicity, it states that statement no pairing of electrons takes place until each orbital having same energy is accommodated singly. Andre ಎಲ್ಲೋ ಆರ್ಬಿಟಲ್ಸ್ ಸಿಂಗಲ್ ಆಗಿ ಅಂದ್ರೆ ಒಂದೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಆಕ್ಯುಪೈಡ್ ಆಗುವವರೆಗೂ ಯಾವುದೇ ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಪೇರ್ ಅಪ್ ಆಗೋದಿಲ್ಲ. ದೋಸ್ ಆರ್ಬಿಟಲ್ಸ್ ಹ್ಯಾವಿಂಗ್ ಸೇಮ್ ಎನರ್ಜಿ ಮೀನ್ಸ್ ನೋ pairing of electrons takes place until each orbit filling or each orbital of same energy is filled or occupied singly. Is called Hund's rule of maximum multiplicity or Hund's rule of maximum multiplicity. So observe here, if you take the p orbital, either you take 2p orbitals, 3p or any one among these, either 3p or 2p or 3d, 4d, anyone, just take 3p. If we are taking 2p or 3p, how many orbitals are there here? 3 orbitals. In p shell there is 3 orbitals or 3 subshells or suborbitals. These 3 is pxy, pyz and pzx, right? So here how many electrons will be occupied? Maximum 6 electrons, because each orbital having 2 electrons with opposite spin. That is the Pauli's exclusive principle. And the Hund's rule says that among these 3 p orbitals, these 3 having same energy, that is 3 and p, means for n value is 3 here and l value is 1. Totally there is 4. Means the energy of these orbitals is 4. It means all these 3 having same energy, that is 4. In such cases, the electrons is filled singly to each orbit, then only the next coming and newly coming electron will be filled the orbital that having lowest energy or previously filled one. ಯಾವುದು ಫಸ್ಟ್ ಫಿಲ್ ಆಗಿರುತ್ತೋ ಅದಕ್ಕೆ ಮತ್ತೆ ಹೋಗಿ ಪೇರ್ ಅಪ್ ಆಗುತ್ತೆ. ಅಲ್ಲಿವರೆಗೂ ಯಾವುದೇ ಆರ್ಬಿಟಲ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಪೇರ್ ಆಗೋದಿಲ್ಲ. ಯಾವಾಗಂದ್ರೆ ಎಲ್ಲ ಆರ್ಬಿಟಲ್ಸ್ಗೂ ಸೇಮ್ ಎನರ್ಜಿ ಇದ್ದಾಗ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ದಿ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಫ್ Hund's rule of maximum multiplicity. Now based on these 3 rules, there is one more rule, that is n plus l rule. So after studying n plus l rule, we can going to study the electronic configuration. Now take the 4th rule is n plus l rule. The 4th one is n plus l rule. This n plus l rule states that two orbitals having different n plus l values, then the orbital which having lowest n plus l value is filled first, then the orbital which having highest n plus l value. It means the electrons are filled first which having lowest n plus l value, then orbital having highest n plus l value. ಸೊ ಇಲ್ಲಿ ಏನು ಹೇಳ್ತಿದೀವಿ ಅಂದ್ರೆ n plus l value ಸ್ಟೇಟ್ಮೆಂಟ್ ಯಾವ ಆರ್ಬಿಟಲ್ಸ್ ಗೆ ಲೋಯೆಸ್ಟ್ n plus l ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೋ, n plus l ವ್ಯಾಲ್ಯೂ ಲೋಯೆಸ್ಟ್ ಇರುತ್ತೋ ಅದು ಫಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಫಿಲ್ ಮಾಡುತ್ತೆ, ಮತ್ತೆ ಯಾವ ಆರ್ಬಿಟಲ್ ಗೆ ಹೈಯೆಸ್ಟ್ n plus l ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೋ ಅದು ನೆಕ್ಸ್ಟ್ ಫಿಲ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳುತ್ತೆ. ದಟ್ ಈಸ್ n plus l ವ್ಯಾಲ್ಯೂ. if two orbitals having same n plus l value, then the orbital which having lowest n value is filled first, then highest n value. So this is the rule. If any two orbitals having the same n plus l value, then the orbital which having the lowest n value is filled first, then the orbital having highest n value. Okay, so this is the statement of n plus l value or n plus l rule. ಅಂದ್ರೆ ಏನೇಳ್ತೀನಿ ಅಂದ್ರೆ ಯಾವುದಾದ್ರು ಎರಡು ಆರ್ಬಿಟಲ್ ಡಿಫ್ರೆಂಟ್ n plus l ವ್ಯಾಲ್ಯೂ ಇದ್ರೆ ಯಾವುದಕ್ಕೆ ಕಡಿಮೆ n plus l ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೋ ಅದು ಬೇಗ ಫಿಲ್ ಆಗುತ್ತೆ, ನೆಕ್ಸ್ಟ್ ಜಾಸ್ತಿ ಇರೋದು ಫಿಲ್ ಆಗುತ್ತೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಅದೇ ರೀತಿ ಎರಡು ಆರ್ಬಿಟಲ್ಸ್ ಎನಿ ಟೂ ಆರ್ಬಿಟಲ್ಸ್ಗೆ n plus l ವ್ಯಾಲ್ಯೂ ಸೇಮ್ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, ಯಾವುದಕ್ಕೆ n ವ್ಯಾಲ್ಯೂಸ್ ಕಡಿಮೆ ಇರುತ್ತೋ n ವ್ಯಾಲ್ಯೂಸ್ ಅದನ್ನ ಫಸ್ಟ್ ಫಿಲ್ ಆಗುತ್ತೆ, ದೆನ್ ದಿ ಆರ್ಬಿಟಲ್ ವಿಚ್ ಹ್ಯಾವಿಂಗ್ ಹೈಯೆಸ್ಟ್ n ವ್ಯಾಲ್ಯೂ. ಓಕೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಅಬ್ಸರ್ವ್ ಹಿಯರ್. Take this 3s and 3p. Take 3s and 3p. For example, I take 3s. And 3p. So here the n value for 3s is n is equal to 3 for this one. This is the n values 1, 2, 3, 4, 5, 6. These are the n values. For 3s orbital, the n value is what? 3. And the L value is 0. Okay, you know I told you the L values L is equal to 0, 1, 2, 3, so on like that, and the S value is 1, 2, 3, sorry not S value, N values is 1, 2, 3, so on like that they started. If N value is 0, then we call S orbital, right? And if N value is 1, then we call P. If 2, D, 4, F, we are writing like that by using azimuthal quantum number L. Similarly, for S, the L value is what? 0. See, the L value is 0, then we call S orbital. So S is 0, means L is 0 for 3s. Now add these to N plus L. What is the N plus value here? 3. So here the N plus value is 3. And similarly for this one, the N value is how much? 3. And the L value is for P orbital 1, right? 1. So N is 1. So by adding these two you get N plus value. Here how much? 4. So among these two, which one having highest and lowest N plus value? 3s having lowest N plus value and 3p having highest N plus value. Therefore 3s is filled first, then 3p. So immediately first 3s fill up. So that's the arrow mark is showing like that. Means 3s is filled first, then after 3p. So observe here these two means the 4p and 5s. 4p and 5s. Now take 4p and 5s. 4p and 5s. For 4p, the N value is what? 4. And the N value is how much? For p, 1 right there. So 1. Now add N plus N. N plus L is equal to 4 plus 1, 5. Now 5s observe here, the N value is how much? 5. And the L value is how much for S? 0. See, the L value is 0, then we call S. So 0. Now add N plus L. How much you get? 5 plus 0 you get 5 only, right? So here observe, the N plus L value is same. If N plus L value is same, then the orbital which having the lowest N value is filled first, then orbital which having highest N value. So here observe, when N plus L is same, we have to observe the N values. Among these two, which one having lowest N value? 4p. So 4p is filled first, then 5s. See here, 4p is filled first, then 5s, right? So that is the rule of N plus L value. Now we are going to study electronic configuration based on these rules, means these 4 rules. The next concept is electronic configuration. Electronic configuration is defined as filling of electrons in various orbitals is called electronic configuration. That is, electronic configuration is defined as filling of electrons in various orbitals. Various orbitals is called electronic configuration. Important definition for 1 mark. Electronic configuration is defined as the filling of electrons in various orbitals is called electronic configuration. All those 4 rules and electronic configuration is very, very important. Whatever we are doing today class is very important for your exam purpose. So example, now take hydrogen. So hydrogen, the element is H and the atomic number is 1. So you know the symbol is H and the atomic number is 1. So write the electronic configuration. The electronic configuration for hydrogen is how many electrons are there? Only 1 electron. The first orbital is 1s, right? So the electronic configuration of hydrogen is 1s 1. The s orbital having only 1 electron. So this is represented in orbital diagram. This is 1s. How many electrons are there? Only 1 electron. So write like that. Either it will be up spin or down spin, but most of the cases it has positive up spin, right? That is plus half when we are seeing only 1 electron. Then similarly take next one, helium. Helium, the symbol is He and the atomic number is 2, right? So write its electronic configuration, that is helium-2. The electronic configuration is 1s2. We know each orbital having maximum how many electrons? 2 electrons only. That is says Pauli's. So here write s orbital. There is only one. That is 1s orbital. That is 1s2 electrons. One is upside, one is downside. That is says that Hund's rule of maximum multiplicity. Hund's rule says that 2 electrons is accommodated in each orbital with opposite spin, right? That is opposite spin with 2 electrons. Similarly, now write carbon or some other, take a carbon. For example, take a carbon. Carbon symbol is C and the atomic number is 6, right? Carbon 6, you know. So now write the electronic configuration. Electronic configuration is, so first see how many electrons are there? 6 electrons in carbon. Now see the orbital energy here. Based on this we are filling the electrons. Now take first one, that is 1s. In S has maximum 2 electrons, right? That is 1s2. Put comma because this is first shell. This is called K shell. Then this is what? L shell. M, N, O, P, like that. So write comma. Then second one, 2s. See, 1s completed, then 2s. 2s having maximum 2 electrons only. There is only one orbital. Then 2p. After 2s, 2p and 3s. 2p, right? 2p. Don't write comma because 2s and 2p having same energy. That is n values remain same. So those two having same energy. The orbitals which having same n values, those having same energy. That is 2p. 2 and 2, 4 electrons is already filled out of 6, and how many electrons will be left? Only 2. Those two right here. But the p orbital having maximum ability to fill 6 electrons. Out of 6 we have only 2 electrons, right? This is the filling of electrons. Now to write the orbital diagrams. Orbital is writing like boxes. Now 1s, right here 1s. How many electrons? 2 electrons. Write 2 electrons with opposite spin. So 2s, right? 2s, only one orbital in s, that is 2s, 2 electrons. These two write with opposite spin. Then 2p. So in p there is 3 orbitals, right? That is 2px, 2py and 2pz. But for s there is no directional, hence we are saying only s orbital. But in p there is a directional, hence one is 2px. Y, that is 2pyz and 2pzx, like that we are indicated. How many electrons are there in 2p? There is 2 electrons. These 2 is filled either here, 1 and 1 here, and there is no, either here and here, anywhere or here and here. Like that there is filled 2 electrons, but not like in same orbit it ever filled like that, because it goes against Hund's rule. What Hund's rule says that ಅಂದ್ರೆ ಈ ತರ ಫಿಲ್ ಮಾಡಿದ್ರೆ Hund's rule ಗೆ ಅಗೇನೆಸ್ಟ್ ಆಗುತ್ತೆ, ಆಪೋಸಿಟ್ ಆಗುತ್ತೆ, ಡೆಡ್ ಆಪೋಸಿಟ್. ಸೊ ಈ ರೀತಿ ಹಾಕಬಾರ್ದು ಅಂತ ನಾವು ಏನು ಹೇಳ್ತಿದ್ದಾರೆ, Hund's ಅವರು ಹೇಳಿರೋದ್ರಿಂದ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಒಂದೊಂದು ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ ಫಿಲ್ ಆಗುತ್ತೆ. ಇವೆರಡು ಯಾವಾಗ ಪೇರ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಇದರಲ್ಲಿ ಒಂದು ವೇಳೆ 4 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇತ್ತು ಅನ್ಕೊಳ್ಳಿ, 2p4 ಅಂತ ಇದ್ದಾಗ ಏನಾಯ್ತು, ಇಲ್ಲೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನಮಗೆ 3 ಎಲ್ಲಾನು ಆಫ್ ಫೀಲ್ಡ್ ಆಯ್ತು, ನೆಕ್ಸ್ಟ್ 4th ನಮಗೆ ಇನ್ ಫಿಲ್ ಆಗುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಲ್ಲ? ದಿಸ್ ಇಸ್ ದಿ ರೂಲ್ ಟು ಫಿಲ್ಲಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬೈ ಅಪ್ಲೈಯಿಂಗ್ all those 3 rules and n plus l rule. Okay, similarly now write the electronic configuration of nitrogen, oxygen, so on. How this element. Now take some examples, means main 2 examples, those having some exclusion, that is chromium and copper. We have to see those electronic configuration now. See, now example we are taking chromium, its atomic number is 24. Right, its electronic configuration like that by filling electrons. So how many electrons are there? 24 electrons. Now write its electronic configuration is, electronic configuration for chromium 24 is 24 electrons, that is 1s2, 2 electrons and 2s2, then 2p6, after 2p there is 3s. Put comma 3s2, then after 3s 3p and 4s. 3p, the p orbitals having maximum 6 electrons, right? 3 orbitals 6 electrons. Then 3p 4s2, 3p 4s2. Then after 4s 3d. 3d4. See, there is 24 electrons. 2 plus 2 plus 4. These 3 is 10 electrons. And 2 plus 2 plus 2. That's 6 plus 2 plus 2, 10 electrons and 4 electrons. How many electrons are there? 10 plus 10 plus 4. 24, right? Means the electrons filling is completed. This is the electronic configuration we get by applying the Hund's rule, Pauli's exclusive principle and Hubble principle, then n plus l value or l plus l rule. But actually this is wrong filling of electrons because in 4s2 there is 2 electrons and 3d4 electrons, but the actual electronic configuration in outermost shell is 4s1 and 3d5. ಅಂದ್ರೆ ನಾವು ಈ ಎಲ್ಲ ರೂಲ್ಸ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಿ ಫಿಲ್ ಮಾಡಬೇಕು. ಈ ತರ ಬರುತ್ತೆ ನಮಗೆ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್. ಆದ್ರೆ ನಮ್ಮ ಎಲಿಮೆಂಟ್ ಕ್ರೋಮಿಯಂ ಅಲ್ಲಿ ಈ ತರ ಇರೋದಿಲ್ಲ, ಈ ತರ ಇರುತ್ತೆ 4s1 and 3d5 ತರ ಇರುತ್ತೆ. ಸೊ ಯಾಕೆ ಈ ತರ ಇರುತ್ತೆ ಅಂದ್ರೆ ದಿಸ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಲೀಡ್ಸ್ ಸಮ್ ಎಕ್ಸ್ಟ್ರಾ ಸ್ಟೆಬಿಲಿಟಿ. ಈ ತರ ಹಾಕೋದು ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಏನಾಗುತ್ತಂದ್ರೆ ಕ್ರೋಮಿಯಂ ಅನ್ನೋದು ತುಂಬಾ ಸ್ಟೇಬಲ್ ಆಗಿ ಇರೋದಕ್ಕೆ ಹೆಲ್ಪ್ ಮಾಡುತ್ತೆ. ಇದು ಅನ್ಸ್ಟೇಬಲ್ ಆಗುತ್ತೆ, ಸ್ಟೇಬಲ್ ಆಗುತ್ತೆ because half filled and complete filled orbitals having attained some extra stability. ಅಂದ್ರೆ half filled ಮತ್ತೆ complete filled ಆಗಿರುವಂತಹ ಆರ್ಬಿಟಲ್ಸ್ ಸ್ವಲ್ಪ ಎಕ್ಸ್ಟ್ರಾ ಸ್ಟೇಬಲ್ ಆಗುತ್ತೆ. ಅದು ಯಾವ ತರ ಅಂದ್ರೆ ಹೈ ಎನರ್ಜಿ ಎಕ್ಸ್ಚೇಂಜ್ ಬಿಟ್ವೀನ್ ಆರ್ಬಿಟಲ್ಸ್. ಎರಡು ಆರ್ಬಿಟಲ್ಸ್ ಅಥವಾ ತುಂಬಾ ಆರ್ಬಿಟಲ್ಸ್ ಮಧ್ಯೆ ಎನರ್ಜಿ ಎಕ್ಸ್ಚೇಂಜ್ ಆಗುತ್ತೆ, ಅದು ಎಕ್ಸ್ಟ್ರಾ ಸ್ಟೆಬಿಲಿಟಿಗೆ ಲೀಡ್ ಮಾಡುತ್ತೆ. ಅಥವಾ ಈ ತರ ಅಂದ್ರೆ ತೋರಿಸುತ್ತೆ ಅಂತ. ಸೊ ದಿಸ್ ಇಸ್ ದಿ ಆಕ್ಚುಯಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಆಫ್ ಕ್ರೋಮಿಯಂ. ಇಟ್ ಮೀನ್ಸ್ ದಿ ಕ್ರೋಮಿಯಂ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d5. Or you can write after 3p6, 3d5 and 4s1 like that. You can write like by alternating these two, here no problem. So this is the wrong way and this is the right way of filling electrons, because observe in 4s there is only one orbital and one electron. Itara bariyutte. Okay. Similarly 5d alli ಎಷ್ಟು orbitals irutte? d alli 5 orbitals. 3d alli d alli 5 orbitals iruttalla, ಅಂದ್ರೆ dxy, dyz, dzx and dx square minus y square and dz square. So here in these 3d orbitals 5 electrons is there, 1 2 3 4 5. So ಎಲ್ಲಾನು ಆಫ್ ಫೀಲ್ಡ್ ಆಗಿದೆ, ಅಂದ್ರೆ ಎಲ್ಲಾನು ಒಂದೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಫಿಲ್ ಆಗಿದೆ, ಇಲ್ಲಿ ಒಂದು ಫಿಲ್ ಆಗಿದೆ, ಅದರಿಂದ ಎಕ್ಸ್ಟ್ರಾ ಸ್ಟೇಬಲ್ ಆಯಿತು. ಇಲ್ಲ ಅಲ್ಲಿ ನೋಡಿ d ಅಲ್ಲಿ ಏನಾಯಿತು, ಸಾರಿ 4s ಅಲ್ಲಿ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್, d ಅಲ್ಲಿ ಎಷ್ಟಿದೆ 4, ಎಷ್ಟು ಆರ್ಬಿಟಲ್ಸ್ ಇರುತ್ತೆ 5, 1 2 3 4 and 5 orbitals. How many electrons are there? 4, right? Electrons 1 2 3 4, one empty ಇದೆ. ಅಂದ್ರೆ this is completely filled, ಕಂಪ್ಲೀಟ್ ಆಗಿ ಫಿಲ್ ಆಗಿದೆ. this is partially filled or incomplete filled. ಪಾರ್ಷಿಯಲ್ ಆಗಿ ಫಿಲ್ ಆಗಿದೆ ಅಥವಾ ಇನ್ಕಂಪ್ಲೀಟ್ ಆಗಿದೆ, ಸೊ ಇದು ಅನ್ಸ್ಟೇಬಲ್ ಆಗುತ್ತೆ. ಇಲ್ಲಾಂದ್ರೆ ಎಲ್ಲಾನು ಅರ್ಧ ಕಂಪ್ಲೀಟ್ ಫಿಲ್ ಆಗಿದೆ, ಮೀನ್ಸ್ ಹಾಫ್ ಫಿಲ್ ಆಗಿದೆ ಎಲ್ಲಾನು, ಸೊ ದಟ್ ಲೀಡ್ಸ್ ಟು ಎಕ್ಸ್ಟ್ರಾ ಸ್ಟೆಬಿಲಿಟಿ. Similarly you can observe in copper. So copper, its atomic number is 29. So write its electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6 and 3d2. So 3p6, then 4s2 after 3p. See 4s2 after 4s there is 3d, 3d 9. So this is the electronic configuration we can write by applying the rules. But actually this is wrong, because in the last valence shell the exchange of electrons takes place between 4s and 3d, 4s and 3d, that is 4s1 and 3d10. ಇದೇನಾಗುತ್ತಂದ್ರೆ ಈ ತರ ಅಟೈನ್ ಆಗುತ್ತೆ. ಯಾಕೆ ಈ ತರ ಅಟೈನ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, 4s ಅಲ್ಲಿ ಒಂದೇ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ, 3d ಅಲ್ಲಿ 10 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ. ಇದು ಕಂಪ್ಲೀಟ್ ಫಿಲ್ ಆಯಿತು, ಇದು ಹಾಫ್ ಫೀಲ್ಡ್ and completely filled. So ಇಲ್ಲಾದ್ರೆ ಇದು completely filled and this is partially filled or incompletely filled. So ಯಾವ ಎರಡು ಹಾಫ್ ಫೀಲ್ಡ್ ಇರಬಹುದು, ಎರಡು ಕಂಪ್ಲೀಟ್ ಫೀಲ್ಡ್ ಆಗಿರಬಹುದು, ಅಥವಾ ಒಂದು ಹಾಫ್ ಒಂದು ಕಂಪ್ಲೀಟ್ ಫೀಲ್ಡ್ ಆಗಿರುತ್ತೆ, ಅದು ತುಂಬಾ ಸ್ಟೇಬಲ್ ಅಟೈನ್ ಆಗಿರುತ್ತೆ ಕಂಪೇರ್ ಟು ದಿ partially filled orbitals. Therefore the right electronic configuration of chromium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d10 is the right electronic configuration important for the purpose of examination. Definitely they will ask anyone out of these two to write the electronic configuration. So here for chromium and copper we are writing the electronic configuration like that rather than like. This is due to some extra stability of half field and complete field orbitals. Half field, that is extra stability of half field and complete field of orbitals. This is the first factor, extra stability, and the second one is exchange energy. Exchange energy means energy exchange takes place between the two orbitals. These are the two factors that leads to extra stability of this half field and complete field orbitals. For example, we are taking chromium and copper. Okay. But other than these two, remaining elements of up to 30 electron configuration will be applicable all those four rules. Means Ohm's rule, Einstein's rule, Pauli's exclusive principle, and first one Hubble principle, then n plus L rule. Okay. So here, what is mean by half field and complete field? Already I told you, this is a half field and this is half field. These two are half fields. These two are half fields. Both are half fields. And here this is completely filled orbital and this is partially filled or incompletely filled. Here these two, one is complete filled, one is half filled, and this is completely filled, this is partially filled or half filled, incomplete filled one. Then what is meant by exchange energy? So here observe, there is 1s electron in 4s, there is only one electron, and in 3d there is 10 electrons. How many orbitals are there? 10 orbitals in 3D. That is 3D, 5 orbitals, 10 electrons. 1, 2, 3, 4, 5. Like that we are filling half field. Then 6, 7, 8, 9, 10. So here observe the exchange of electrons will be takes place in 3D. He is 1 electrons from these 4 orbitals like that. ಅಂದ್ರೆ ಇದರಲ್ಲಿರುವಂತ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಈ 4 ಜೊತೆ ಎಕ್ಸ್ಚೇಂಜ್ ಆಗಬಹುದು ಅಥವಾ ಇವೆರಡರಲ್ಲಿರುವಂತ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಈ 3 ಜೊತೆ ಎಕ್ಸ್ಚೇಂಜ್ ಆಗಬಹುದು. ಓಕೆ, ಇಲ್ಲಾಂದ್ರೆ ಈ 3ರಲ್ಲಿರುವಂತ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇವೆರಡರ ಜೊತೆ ಎಕ್ಸ್ಚೇಂಜ್ ಆಗಬಹುದು. ಈ ರೀತಿ ಎಕ್ಸ್ಚೇಂಜ್ ಮಾಡ್ತಾ ಇರುವಾಗ ನಮಗೆ ಗೊತ್ತಾಗೋದಿಲ್ಲ ಐಡೆಂಟಿಫೈ ಮಾಡೋದಕ್ಕೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಅಬ್ಸರ್ವ್ ಹಿಯರ್, ದೇರ್ ಇಸ್ 2 electrons here. These 2 will be filled here. And here there is 2 electrons, right? Those 2 are writing here. Now the filling of electrons will be remains same. We are unable to identify. Similarly, if these 2 are exchanged here, or these two, we can't able to identify the electrons where they are exchanged. When the electrons will be exchanged between the orbitals, it releases some energy. That leads to the stability of orbitals. ಯಾವಾಗ ಎನರ್ಜಿ ಕಳ್ಕೊಂತಾ ಇರುತ್ತೋ ಅವಾಗ ಸ್ಟೇಬಲ್ ಆಗಿರುತ್ತೆ. ಸೊ ನೀವೇ ನೋಡಿಬಹುದು, ನೀವೇನಾದ್ರೂ ಜಾಸ್ತಿ ಎನರ್ಜೆಟಿಕ್ ಆಗಿದ್ರೆ ಒಂದೇ ಕಡೆ ನಿಂತ್ಕೊಂಡಿರೋದಿಲ್ಲ, ಓಡಾಡ್ತಾ ಇರ್ತೀರಾ, ಜಾಸ್ತಿ ಎಕ್ಸೈಟ್ ಆಗಿರ್ತೀರಾ, ಎಲ್ಲರನ್ನೂ ಡಾಮಿನೇಟ್ ಮಾಡ್ತಿರ್ತೀರಾ. ಅದೇ ರೀತಿ ಸ್ವಲ್ಪ ಆಯಾಸವಾಗಿದ್ರೆ ಅಂದ್ರೆ ಸ್ವಲ್ಪ ಸುಸ್ತಾಗಿದ್ರೆ ನೀವೇನ್ ಮಾಡ್ತೀರಾ, ಒಂದೇ ಕಡೆ ಸ್ಟೇಬಲ್ ಆಗಿ ಕೂತ್ಕೊಂಡ್ಬಿಡ್ತೀರಾ, ಯಾರನ್ನೂ ಮಾತಾಡ್ಸೋದಿಲ್ಲ. ಲೈಕ್ ದಟ್ ವೆನ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಸ್ ಎಕ್ಸ್ಚೇಂಜಸ್ ಬಿಟ್ವೀನ್ ದಿ ಆರ್ಬಿಟಲ್ಸ್, they loses energy. When they are losing energy, they becomes not exciting, means they are not exciting. At that time they are attain stability. Okay, so that is the extra stability. These are the 2 factors that leads to the extra stability of electron configuration. Example, we are taking chromium and copper. So here the structure of atom chapter is completed. I will give homework for some questions. You should answer and submit.